Chapter 3, Gaseous States of Matter. Gaseous state is the third state of matter in the periodic table. Oxygen, nitrogen, helium, neon, argon, etc. are several gases. These gases obey certain laws. These are given below. Gas law 1. Boyle's law. According to this law, at constant temperature, the volume of a given mass is inversely proportional to its pressure. If V is the volume and P is its pressure, then according to Boyle's law, V is inversely proportional to pressure at constant temperature. In other words, PV, pressure multiplied by volume, is equal to A. A is constant. That is, at constant temperature, the product of pressure and volume of a given mass of a gas is constant. If V1 and V2 are the volume of a given mass of a gas at pressure P1 and P2 respectively, then according to Boyle's law, P1 V1 is equal to constant and P2 V2 is equal to constant. Hence, P1 V1 is equal to P2 V2 at constant temperature. Second, Charles' law. At constant pressure, a gas will expand by 1 upon 273 of its original volume at 0 degrees Celsius for every 1 degree Celsius rise of temperature, and will contract by 1 upon 273 of its original volume at 0 degrees Celsius for every 1 degree Celsius fall of temperature. If V0 and V1 are the volume of a gas at 0 degrees Celsius and T degrees Celsius respectively, then by Charles' law, Vt is equal to V0 plus V0 upon 273 multiplied by T temperature. Let V0 and V1 be the volume of a given gas at 0 degrees Celsius and at T degrees Celsius respectively. Then V multiplied by T is equal to V0 plus V0 upon 273 multiplied by T. V0 multiplied by 1 plus T upon 273. V0 is in bracket 273 plus T upon 273. V0 multiplied by T upon 273. Therefore, 273 plus T degrees Celsius equal to T K, or V T upon V0 is equal to 2 of T upon 273. If T0 and T1 represent the temperature at 0 degrees Celsius and T degrees Celsius on the absolute scale, then Vt is equal to V0 multiplied by T upon T0, or Vt upon V0 is equal to T1 upon T0. In general, if V1 and V2 are the volume of a given mass of a gas at the absolute temperature T1 and T2 respectively, then V1 upon V2 is equal to T1 upon T2. At constant pressure, the volume of a given mass of a gas is directly proportional to its absolute temperature. V is directly proportional to T, P constant. Third, Gay-Lussac's law, a law of pressure 1802. If the volume of a given mass of a gas be kept constant but temperature is raised, then the pressure increased by 1 upon 273 of its original pressures at 0 degrees Celsius for every 1 degree Celsius rise of temperature. This relationship can be expressed as Pt is equal to P0 plus P0 upon 273 multiplied by T, or Pt is equal to P0 multiplied by 1 plus T upon 273, where P is equal to pressure at 0 degrees Celsius and Pt is equal to pressure at T degrees Celsius. Gay-Lussac law states as follows: at constant volume, the pressure of a given mass of a gas is directly proportional to its absolute temperature. P is directly proportional to T, or P1 upon T1 is equal to P2 upon T2. Fourth, Avogadro's law. Equal volume of all gases under the similar condition of temperature and pressure contain equal number of molecules. This is called Avogadro's law. At constant temperature and pressure, V is directly proportional to N. V is equal to volume of gas and N is equal to number of gas molecule. Since the number of molecule in a mole of any gas is same, the amount of the gas is generally expressed in moles. Avogadro's law then may be modified as equal volume of all gases under the similar condition of temperature and pressure contain equal number of moles. Thus V is directly proportional to N, where N is equal to number of moles, or V is equal to Kn. This can be brought to the more suitable form. V1 upon N1 is equal to V2 upon N2. Standard temperature and pressure. The temperature of 0 degrees Celsius 273 Kelvin is taken as the standard temperature. The pressure of 760 millimeter 1 atmosphere is taken as the standard pressure. These are taken as a normal temperature and pressure, NTP or STP. Ideal gas equation. Ideal gas equation is obtained by combining three laws, namely Avogadro's law, Boyle's law and Charles' law. Here P is equal to pressure of a gas, V is equal to volume of the gas, N is equal to number of moles of gas, and T is equal to absolute temperature for 1 mole of a gas. N is equal to 1. Then PV is equal to RT, or PV upon T is equal to R constant. Values of a gas constant is R equal to 1 atmosphere multiplied by 22.4 liter upon 1 mole multiplied by 273 Kelvin is equal to 0.0821 liter atmosphere per Kelvin per mole. When the pressure P is in millimeter instead of in atmosphere, the value of R is 62.4 liter mmK per mole. R is equal to P pressure multiplied by volume V upon T temperature, equal to 76 multiplied by 13.6 multiplied by 980 multiplied by 22.4400 upon 273 equal to 83.14. 10 multiplied by 10 raised to 7 ergs per degree per mole, CJ's unit. But 10 raised to 7 erg is equal to 1 joule. R is equal to 8.314. 10 raised to 7 upon 10 raised to 7 is equal to 8.314 joule per Kelvin per mole SI unit. 1 calorie is equal to 4.18 joules is equal to 8.314 upon 4.18 is equal to 1.987 calorie per Kelvin per mole. Gram molecular volume, GMV. 1 gram moles of any gas at normal temperature and pressure occupies a volume of 22.4 liter. This volume is called as a gram molecular volume, also known as gram molecular volume. The mass in gram of 22.4 liter of any gas at NTP is its gram molecular weight, GMV. The molecular mass of oxygen is 32. At NTP, 32 gram of oxygen occupy 22.4 liters. Similarly, 44 gram of carbon dioxide occupy 22.4 liters. Number of moles is equal to weight upon molecular weight. Diffusion of gases. The intermixing of two or more gases to form a homogeneous mixture is known as diffusion of gases. Graham's law of diffusion. At a given temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square roots of its density. R is inversely proportional to square root D, where R is rate of diffusion, D is density of the gas. At the rate of diffusion of two gases is R1 and R2, their densities and are D1 and D2 respectively. The law can be expressed as R1 inversely proportional to square root D1 and R2 is inversely proportional to D2, or R1 upon R2 is equal to square root D2 upon D1. If V is the volume of a gas of molecular weight m at a given temperature, Then its density is small d is equal to m capital M upon capital V. Density is equal to mass upon volume under the similar condition of temperature and pressure. Let d1 is equal to density of a gas of a molecular weight m1 and d2 is density of the other gas of molecular weight m2. Then d1 upon d2 is equal to m1 upon m2. R1 upon R2 is equal to d2 upon d1 is equal to square root m2 upon m1. Effusions. When a gas is allowed to come out from its container through a small hole into vacuum, it is called effusion. Graham's law of diffusion is equally applicable to the effusion of gases. Dalton's law of partial pressure. At a given temperature, the total pressure exerted by a mixture of gases which do not chemically react with each other is equal to the sum of the partial pressure of the individual gases. P is equal to P1 plus P2 plus P3 and so on. Kinetic theory of gases. A gas is composed of very large number of tiny particles called molecules. The actual volume of all gases is negligible compared to the total volume of the gas. Second, the molecule of a gas move randomly in all directions in straight line. They collide with each other and with the wall of the container. Third, molecules are hard elastic spheres. They make elastic collisions. Fourth, there are no force of attraction or repulsion between the gas molecule. Fifth, the average absolute temperature of the gas, that is Ke directly proportional to T. Kinetic gas equation PV is equal to 13 mnc square. C is equal to square root 3 RT upon M. C is equal to square root 3P upon D. Average velocity is equal to 0.9213. RMS velocity Cp bar C is equal to 1 is to 1 is to 128 1.224. Ideal gas. Ideal gases are those which obey gas law at all temperature and pressure.